video is in 4 parts: the big idea, the prerequisites, the key teaching ideas, and why I think teaching place value is so important. So when I start thinking about planning to teach place value, I think about which aspects I really want my pupils to get a good, secure and deep understanding of by the time we come to the end of our learning on place value. For me, part of that is about pupils having an understanding or an idea, an appreciation of really big and really small numbers. It's also about having an understanding that in the UK, we mostly use a base 10, a denary system, and that lots of their understanding needs to be around powers of 10 and the importance of multiplying and dividing by 10. So for me, learning about place value is in 3 separate aspects: scaling, position and quantity. And having an understanding of place value in these 3 different areas will really give a secure and deep understanding. So firstly, to have a think about scaling. This is a task I use with my pupils sometimes as a bit of a hook lesson when we start thinking about place value. Place value is so abstract, and sometimes I think using measure as a context for place value really helps secure some of that understanding for some pupils. So this is a picture taken from Google Earth of the globe at 10 million metres. So this picture was taken 10 million metres away. And now at just 1 million metres, so 1/10 of the distance, 10 times nearer, we can just see England. We can't see the whole globe anymore, we can just see England. And by going through these different images, getting 10 times nearer or 1/10 as far each time, I can start to give pupils an idea of the importance of multiplying and dividing by 10 and the power that has. So when we're only 10 metres away, we're really focusing on a very small part of the palace, and then 1 metre away we can see who's looking out the window. But using that language around 1/10 as far or 10 times nearer, that multiplicative language is really key when we're thinking about scaling. So another aspect of place value for me is position, numbers in relation to other numbers. So having an appreciation of really big numbers and really small numbers and how they are related to each other, position on a number line. So starting off with an image that they're probably really familiar with, this idea of a number line. I like my number line to have arrows going in both directions to give the impression that numbers are infinite and they go on indefinitely in both directions. We're only going to think about positive numbers on my next few slides, but it might be worth commenting that the same is exactly true for negative numbers also. So this is an image I hope that most of them would be familiar with. And we can talk about zooming in and zooming out like you might have done with the Google images to make the connections. So starting making connections between that 0 to 1 number line and then that 0 to 10 number line. We're talking about base 10, there are 10 digits. I'm starting to make those connections between the numbers. And we're zooming out again, so starting to include hundreds now. We could talk about the similarities between the 0 to 10 number line and the 0 to 100 number line. And we can focus in on just a part of that and draw attention to the fact that that 0 to 100 number line also has part of it as a 0 to 10 number line. So we can focus in on that. Getting in some big numbers now, 0 to 1,000 number line, and then 0 to 10,000 number line. So increasing in size by a power of 10 each time, and looking for similarities, what's the same and what's the different about these number lines. It's also quite a nice activity to track a number, so mark a number on your number line and then see where that would be on the other number lines that are have larger powers of 10 marked on them. So then we can also zoom in. So we're going back down again now. So we've only got a 0 to 1,000 number line, zooming back in, and we're back to where we started, 0 to 1. But actually we can zoom in again. Some pupils might have had a limited exposure to different number lines, might not have seen non-integers on a number line before. So this is a nice introduction to having numbers that aren't integers on a number line. And again, looking for those similarities. What's the same and what's different between this number line, or this part of the number line, and maybe a 0 to 10 number line. So looking for those similarities and making connections. And we can zoom in again. And again, we've got those markers on there to show that actually we can get even smaller. And zooming in. Another important aspect of place value is this idea of quantity, that each of these numbers has a how many. I have more than or less than, that language around more than and less than comes in when we talk about quantity. So there's my one. I'm trying really hard to use the word one when I mean ones, talking about one single ones, and units when I'm talking about measures, length or volume. So this is a one, not a unit, and we're talking about ones column. So there's my 10 times as many. These visual representations, again, representations being really, really key when we're talking about such an abstract concept as place value. And that actually we can do some exchanging. So those 10 ones can be exchanged for 1 10, and 10 tens can be exchanged for 100, and 10 hundreds, 10 times as many, can be exchanged for 1,000. And those 10,000s, what might that look like as ones? Well, it's lots of ones. There's another task in the supporting document, which is again quite a fun hook when we're thinking about place value estimation and rounding. So what things typically go wrong? Pupils still think that they can move a decimal point, still think it's a decimal point that moves, rather than having this kind of understanding, this appreciation of increasing or decreasing by a value of a power of 10. Pupils might think number lines only can have integers. Pupils might think that you should always look at the last digit to determine the rounding of a number. Pupils might say things like 3,654 rounds to 700. Pupils might say 5 rounds up and have an algorithm that they remember, 1, 2, 3, 4 to the floor, 5 to the sky, that kind of thing, kind of trying to move away from those tricks and use language that supports understanding instead. Pupils might talk about adding or taking away a 0 when they're actually multiplying or dividing by a power of 10. So how would I address these misconceptions? I might choose some non-examples to really draw out and highlight these misconceptions. I might choose a question or example that deliberately doesn't fit within their misconception, so where they can't use always using the last digit on the right to determine where a number rounds, if we're rounding to the nearest 100, for example. Or a non-standard example, so not always just rounding to one decimal place fewer than they're given in the question. And I think lots of misconceptions can really be addressed with some well thought out representations and really, really consistent use of language. So, for example, this 3,654 rounding to 700, if we put those numbers on a number line, we can see that 700 isn't actually very close to 3,654, and they actually mean 3,700 rather than just 700. So some really clear and consistent representations that we can be fluent with and use flexibly, I think, are a good way to address lots of the common misconceptions. So the expectations from Key Stage 2 are really quite high, and I would say increasingly, whenever I'm planning for Key Stage 3 lessons, I always look at the programme of study for Key Stage 2 and the NCETM PD materials for Key Stage, the primary PD materials, so I get an idea of the kind of things that are expected of pupils at Key Stage 2. That doesn't necessarily mean that all pupils that come up to school, to secondary school, will have a secure and deep understanding of those outcomes, but it gives me an idea of the kind of thing they might have had exposure to in primary school. So I definitely recommend having a look through the Key Stage 2 programme of study when you're planning any lessons for Key Stage 3. So some of the prerequisite skills that I really hope my pupils can come with are about exchanging groups of 10, including when we're bridging over powers of 10, and using a number line. Really key for me that pupils can use a number line well and fluently access a number line and use it to support their understanding. So exchanging, things like 14 add 18 equals 32. Just the idea that we can exchange 10 of those ones into 110 and we do still have 32. So some representations of that might be useful. And partitioning, I want pupils to be able to partition really successfully. So the 356 is actually 3 lots of 100, 5 lots of 10 and 6 lots of 1 together. So being able to partition a number, and that will support them in other key skills that we expect them to be able to do, multiplying, grid method multiplication, that kind of thing. So I know what I think they should know, but how do I know what they actually know? So I might try some of these diagnostic questions, or the Mastery with Greater Depth is from the primary Teaching for Mastery assessment materials. Some of them are really tricky. I've used some of the primary ones in my Key Stage 3 lessons, and I've used some of the secondary ones right through Key Stage 3 and Key Stage 4 lessons as well. So some of them are quite tricky. I might use these as a think, pair, share activity, just to get my pupils really thinking and to give me some really valuable information about where my pupils are currently working at with their idea and their understanding of place value. And for diagnostic question, maybe something that highlights some of those misconceptions. So some of those rounded figures slightly incorrect, and highlight some of the misconceptions. So useful tool to give me lots of information about my pupils. Okay, so I think now we'll have a look at some of the key messages, and these come from the Key Stage 3 programme of study and also from the NCETM PD materials. So these are really around pupils having a good understanding of place value, the value of digits in numbers, and being able to round and estimate successfully using their understanding. I'm increasingly trying to plan my lessons more broadly. So rather than planning one lesson singly in isolation, which maybe does lead on to or lead on from previous lessons or lessons that I know are coming up, but rather than planning single lessons in isolation, try and make my planning a bit more broad and think about the whole topic and how I want that to pan out. And that really gives me confidence in choosing really coherent representations and being really consistent with my language for that topic from the very beginning. I have previously maybe taught a lesson week 1 and then got to lesson in week 2 and realised actually if I'd used a different representation or used a representation slightly differently, it would have been much more supportive of the whole learning journey to really support pupils' understanding and making those connections. So being able to plan a few lessons or a series of lessons together gives a bit more, for me, gives a bit more of a coherent kind of learning journey and makes me be able to use consistent language from the beginning and be really clear about which representations are going to be really useful for the whole topic. So one of those things is language and being able to use language really consistently. In my school at the moment, we have to be really clear about the Tier 2 vocabulary that we're using in lessons. So some of those common words, value, round, estimate and power, that pupils hear in everyday speech, but have a really, also have a subject specific definition and a meaning within the subject that we're talking about. And pupils being able to use those successfully in their language and in their vocabulary when we're talking about their learning and their understanding. So we have to be really clear about Tier 2 vocabulary, and for me some of those words are words I would consider Tier 2 for this topic. There's also some key vocabulary that maybe is more Tier 3 vocabulary that are really subject specific and maybe wouldn't be used so much in normal speak. So decimal and significant figures. Again, I'm trying really hard to be really clear about digits versus number. So a 1 and a 5 and 7 are digits, but 153 is a number. And when we're talking about place value, it's really good to be able to separate those two. The digit 4 in in a number might have a value of 40. So being able to be really clear about that and being consistent about that use of digit or number from the beginning. I also expect my pupils to be able to answer all of their questions in full sentences. I think that has lots of benefits. It helps me know what they understand rather than assuming what they've understood. It also makes the success be in their reasoning and their understanding rather than just a single word or single number answer. And it really supports other pupils who might not be confident in a classroom to give their answer out loud. They're repeatedly hearing those good examples of full sentences that really clarify understanding and something to work towards, answering in full sentences, and me being able to model answers in full sentences. And I'm certainly trying to avoid language around tricks, fall to the floor, that kind of thing. So yeah, this is just an exemplification of the number 1460, and then each of those, the 1, 4, 6 and 0, each as digits. And then those are some representations. We've talked about the quantity and the position of 1460 in those representations. So yeah, kind of talked about this as a bit already. So rounding, I'm really expecting my pupils to answer in full sentences and being able to use a number line to support their reasoning. So I would expect my pupils, certainly in the early stages, to be drawing a number line for every rounding answer that we go for, rather than just giving me a number, and trying to sort of maybe change their internal dialogue about 5 rounding up, but actually 55 is nearer to 60 than it is to 50. Well, it's not quite, but we need to talk about conventions and mathematical convention. But for all the other numbers, 57 is nearer to 60. So trying to change that kind of internal dialogue. And it's also talking about the conventions that we use so that we have an understanding of maths across the whole maths community. So also thinking about estimating, kind of the difference between estimate, which is a command word in Key Stage 4 exam papers, things that have quite a strict kind of set of expectations around one significant figure or appropriate degree of accuracy, and actually using estimating as a skill that they can use to self-check their answers, and also estimate their answers to make sure their answers are reasonable, using their reasoning to make sure their answers are reasonable. I also really want pupils in my class to kind of move away from this notion that we need an exact answer every time, and an ish answer is something that can be really useful and really valuable in their development. And I want pupils to be happy to give me an ish answer based on their understanding of place value. So this is an example of a question, pretty standard question I think, that I might give to some of my year 8s, around 326 to the nearest 10. So being able to sketch that number line, really focusing on the two ends of the number line being really important. They fit that criteria of being to the nearest 10. Because we're talking about the nearest 10, the ends of my number line need to be tens. They need to be to the nearest 10. If we were talking about hundreds, the ends of my number line could be hundreds. The other really key thing about this number line is the midpoint. So being really aware of the midpoint between those two ends of the number line. And then being able to position on that number line where the 326 sits. It's really important for me that pupils don't draw this with a ruler and measure out each individual bit. It's just a quick sketch with the important parts labelled. So the ends and the middle, and then marking on where that number sits. And it doesn't matter to me if it's slightly further right or slightly further left. The point is that it's between the 325 and the 330 rather than the 325 and the 320. And then I would absolutely expect pupils to be answering with a full sentence, 326 rounds to the nearest 10 to 330, because it's nearer to 330 than it is to 320. That comparison really shows me that this pupil really understands rounding and understands the place value of that 326. Oh, and there's one of my pupils. She's done a nice sketch and that really shows me that her understanding is quite good of rounding, and she's being able to make that comparison. So these are some questions I might use to think about rounding. The The image on the left is a bit of a pick and mix, a bit of a variety of questions, and I'm increasingly kind of trying to use that kind of question set less, where pupils are just kind of working through a set of answers, and maybe trying to think about having a bit of a think about variation and choosing what to vary and what to keep the same, so that I'm drawing attention to the structure of the maths that's happening. So the 163.7 to the nearest 1, 10, 100 and 1,000, I could easily have chosen different numbers with one decimal place each for those 4 different questions, but by keeping the 163.7, I'm drawing attention to the fact that those numbers have a position on the number line, and that's the structure of the math that I want them to be thinking about, rather than just a set of questions that they can round. And similarly, by keeping all of those 40 numbers the same and rounding them to the nearest 10, we're drawing number lines so they can see which numbers round to 50 and which numbers round to 40, and they can start to make their own assertions about what's happening and why it's happening, the what do you notice kind of question. So encouraging them to think about what impact these numbers have when they're being rounded. So here's an example of an estimation question I might ask. Again, fairly standard, nothing particularly special about it, but I want pupils to be able to give me an ish answer for this. So the 0.37 is ish enough to me, a multiple of 6, so I'm going to be thinking about as 0.36 divided by 6. I've chosen a multiple of 6 because I know that my second part is got a 6 in it. And so I'm thinking about 36 divided by 6. So my answer is probably about 6-ish. But it can't be 6 because I started off with 0.37 and I'm dividing that by a whole number. So it must be getting smaller. My answer must be getting smaller. So then it might be 0.6. Well, that's still bigger than the 0.37 that I started with. So maybe it's 0.06. And pupils being able to give me that kind of rounded answer, I'm not particularly interested on someone sneakily doing it on their calculator and giving me the exact decimal. I want them to be able to estimate and use their sense of estimation. If someone gave me an answer of 6 or 0.6, I might explore with them in a bit more depth about the size of the number they're starting with and the value of each of those parts in that number. So some key questions I might ask. Just a selection of questions here that have certainly been influenced from lots of different places. I really like the how do you know question. So rather than pupil give me an answer and straight away receiving a yes or a no or a right or a wrong, a follow-up question of how do you know? So encouraging pupils again to answer in those full sentences and really explain their reasoning. So the focus is on the success being in explaining what they know and their reasoning rather than just a single number or a word answer. The what do you notice? Find another pair and another pair, always, sometimes, never. Really good standard questions that you can use in any topic, any context at all, and they're really kind of probing for those depth. I also like the what could the numbers be, so encouraging people to think more broadly and have a think again, really deepen that thinking, deepen that understanding. So all of those questions have been influenced from lots of different places. Places I definitely go to look, so I think there's links to these in the supporting documents, but places I would definitely go to look are the NCETM secondary assessment materials. I mentioned the primary ones earlier. The primary ones are really good. The second ones are really good too. They're definitely not kind of what they say on the tin. They're not somewhere to go for made up exam paper or a SATs paper or that kind of thing to give pupils to just work through in silence. They're really rich questions that have been really well designed to draw out lots of mathematical themes and structures. And yeah, definitely somewhere to go to look. I definitely recommend those. Enrich, Open Middle, really good websites for kind of those richer, wider tasks. The NCETM PD materials are designed at teachers, so there's not really questions in there, but there are some examples and they're really good places for prompts that I would definitely go when I'm thinking about designing my own questions. And I think it's been recently released, the primary exemplification of ready to progress criteria. Maybe not so much questions, but certainly some really clear explanations and really good visual representations for pupils who need maybe a little bit more support, or some of those pupils that arrive with not quite as deep an understanding as we would like them to have. Definitely somewhere that's really useful to go and have a look for any ideas on supporting that understanding. So this is key representations. We've talked a little bit about a number line. That one in the middle is one I'd really want to use in thinking about rounding and representations. These are lots of different number lines and not necessarily all ones I would choose to use. I'm not sure about the ones with the red and the blue. I think sometimes people use hot and cold for positive and negative, so the red and the blue might be a little bit confusing. I think it's definitely worthwhile though having some number lines with decimals on, or number lines where whole numbers are split into parts, and some number lines with really big numbers in as well. So it's not just always a number line up to 10 or 20. So number lines that you use, I think it's important to choose a number line. I want my pupils to be really fluent with just being able to sketch their own number line, and they can take it with you. I'm trying to use fewer representations that are chosen more carefully, so kind of fewer better representations, and certainly representations that might be useful in lots of different topics, so that pupils can make connections and take their understanding. Oh, if I could do that on a number line, maybe it's connected to this other thing that I can also do on a number line. So kind of fewer better representations that are chosen carefully. So I would definitely say that number lines is one of those. These images, some images like this earlier on, Dean's blocks, these are from MathSpot. Again, the website's in the supporting document. Really, really useful website. It's got great online manipulatives, and I'm really conscious that when I'm planning for my lessons in September, I'm not going to be able to include the physical manipulatives that I might usually choose to, and MathSpot is really, really user-friendly, really easy for staff and pupils to use to give those really good representations. It's also got an exchange function so that pupils can see the 10 being split up into 10 ones. And it's got place value cards and place value counters, so it's a really, really useful website that I'll definitely be using a lot more this year than I might have previously. And a place value table with those names, those place value headers on them, and I think it's quite useful. This is quite a nice example because it's also got the numbers written on there in words and in digits, so that increasing by power of 10. I also think this is really useful for pupils being able to see where the digits are moving and not the decimal place. So this is definitely something I would use when I was trying to address the misconception that it's the decimal point that moves, because absolutely the decimal points are staying the same, and it's the digits that are increasing by a power of 10, increasing in value by a power of 10. So all of those digits are moving into a column to the left when we're multiplying by 10, and equally moving into a column, moving column right when we're dividing by a power of 10. I think this place value table is also really useful for bringing together lots of the different representations. So we've got 37 being multiplied by a power of 10, and actually we can represent that with the Dean's blocks as 37, and we can see that each one of those 10s has become 100. So not just that the digit has moved, but actually the 10 has become 100, and then another 10 has become 100, and each of those ones has become a 10. So it's really useful for kind of making those connections and bringing lots of the representations together in a place value table. So I said at the beginning that I think place value connects to loads of different areas of maths, and these are just from the Key Stage 3 programme study number part, but there's so many different areas of maths that a really good understanding of place value early on really supports. So these are from the Key Stage 3, but looking more broadly into Key Stage 4, things like upper and lower bounds, limits of accuracy, standard form, are all topics which will be much easier for pupils to understand if they've got a really solid understanding, a secure and deep understanding of place value.